Okay, radicals day 3, we're going to look at graphs of square root functions and cube root functions. So first thing we'll do is look at the parent function for a square root. So we need values for x in our chart or our table that are perfect squares. So we'll start with 0. And we know that 1's a perfect square. 4 is a perfect square and 9's a perfect square. So I can't go any larger because of the graph. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and the square root of 3 or 9 is 3. So we can graph these points and sketch the parent graph for the square root of x. So if you notice, it only heads in one direction because we cannot put negative numbers underneath our radical. So my domain is restricted. All values of x such that x is greater than or equal to 0. My range is also restricted. All values of y such that y is greater than or equal to 0. There's no negative values. And for my in behavior, as x goes to negative infinity, in behavior does not exist because I cannot go past x equals 0. I cannot continue on to the left. I can, however, go to the right. So as x heads to infinity, f of x is also growing slowly. It's going to infinity as well. Okay, so the next one is a cube root function. So if you recall from the previous couple days, I can put a negative number under an odd root and come up with an answer. So think of your perfect cubes. I'm going to start in the middle here with 0, 0. We'll go positive first. So 1 and then 2 cubed is 8. So I'm going to go 8 and 2. I can also go backwards with these because the cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. So if I graph these points, I can see the cube root function looks like this. So my domain is all real numbers, and my range is also all real numbers. For my in behavior, I have both left and right. As x goes to negative infinity, f of x is also going to negative infinity. And as x goes to positive infinity, f of x is also going to positive infinity very slowly, but it's the y values are getting larger and larger. Okay, so now we're going to look at transformations. So transformations is something that we've done with every single function that we've looked at this semester. So for these, I'm only going to have you state the domain and range once we get them done. So I'm going to use the same process that I've taught you for every single function that we've looked at. So in this case, I called it y. So since this is a square root, I'm going to start with my parent function. And then I'm going to apply my transformations. So the negative sign is going to reflect over x. And the 2 is going to be a vertical stretch by 2. So those affect both the y values. So first thing I'll do is reflect everything over x. So my 0 stays 0. This becomes a negative 1, a negative 2, and a negative 3. And now I'm going to stretch them by 2 by multiplying by 2. So that's going to stay 0. That'll be a -2. That'll be a -4, and that will be a -8. So this is going to fall quicker. So I'm still at 0, 0. I'm down here at 1, -2, 4, -4, and 9, -8. So this graph is going to fall pretty quickly. Oh, wait a minute. I think I messed up my points here. That one should have been reflected as a -3, and then multiplied by 2 is a -6. I apologize for that. So that's a 9, -6 now. So it should look like this. Okay, so my domain is still all values of x such that x is greater than or equal to 0. My range has changed because it's now negative numbers. So all values of y such that y is less than or equal to 0. Okay, so same idea for a cube root. So I'm going to go ahead and start with my parent function for a cube. So x, y, 0, 0 in the middle, 1 and 8. Cube root of those is 1 and 2. And I can throw in my negatives. So that would be the cube root of -1 and the cube root of -8. So my first transformation is, again, reflect over x. My second one is a vertical stretch by 3/2. So 1.5. Okay, so if I take my y values and I reflect them over x, this is a 2. This is a 1. This is still a 0. This is a -1, and that's a -2. So I did that in green. I meant to do it in red. And now I'm going to multiply them by 3/2. So 2 times 3/2 is 3. This will be 3/2, or 1.5. This is still 0. -3/2. And this will be a -3. So I have -8, -3, -1, 1.5. Nope. That would be a -8, +3. Should be a falling function. -1, +1.5. I'm still at 0, 0. 1, -1.5, and 8, -3. So it's just a little bit steeper in the middle there than the parent function. So my domain, all real numbers, range, all real numbers. Those won't change for a cube root. All right, a couple more with different transformations. So this is a cube root function again. So I'm going to start with my perfect cubes. So 0, 0, 1, 1, 8, and 2. -1, -1, -8, -2. So this one I have 3 transformations. And my first one is reflect over x. Remember, I've always told you to go left to right. That's going to affect the y value. The second one is the +2, so that's going to move it left 2. That's going to affect the x value. And then the down 1, again, that's going to be our y value. So let's reflect over x. So that'll become a positive 2, 1, negative 1, negative 2. And I'm going to go ahead and finish my new f of x, or my y terms. So I'm going to go down 1, so I'm going to subtract 1. So that's going to be a 1. That'll be a 0. That'll be a negative 1, a negative 2, and a negative 3. Okay, so for my left 2, I need to take my x values and subtract 2. So negative 8 minus 2 is negative 10. Negative 1 minus 2 is negative 3. That'll be a negative 2. 1 minus 2 is negative 1. And 8 minus 2 is 6. So if I graph those, negative 10, positive 1. So basically that vertex 0, 0 has moved to negative 2, negative 1. And then I have negative 1, negative 2. Something is wrong there. Oh, never mind. I just put it in the wrong spot. Negative 1, negative 2. And 6, negative 3. 1, 2, 3. So that graph reflected and it shifted left and down. So you can kind of judge it by this point right here. That one went left 2 and down 1. So my domain, still all real numbers. My range, all real numbers, because it's a cube root. All right, so last one. Got quite a few transformations on this one. So this one is a square root. So I have x and g of x, and I need my perfect squares to start with. This one has 4 transformations. So reflect over x. My 2 is a vertical stretch by 2. My plus 1 is going to be my x values, so that's going to go left 1. And then I'm back to my y value for down 3. So my red notations are going to all affect my y value. So let's do those first. So reflecting over x, these are just going to become negative. Then I need to stretch them by 2. So negative 4 and negative 6. And then I need to move them down 3. So I'm going to subtract 3 from each one of them. And negative 9. So my x value needs to go left 1. So I'm going to subtract 1 from all of these. And I have my new points to graph. So I have negative 1, negative 3, 0, negative 5. There I can see my stretch of 2. 3, negative 7. And 8, negative 9. Okay, so I got a little sidetracked because I had cube root in my mind. So this is still a square root function. So it has that end point, or that beginning point right here. Okay, so your domain and range is based on this value right here. So this is negative 1, negative 3. So my domain is that x value. So all values of x such that x is greater than or equal to -1, because that's where the graph starts. And then my highest y value is -3. There's nothing above that. So my range is all values of y such that y is less than or equal to -3. All right, so there is graphing radicals and cube roots. I don't think you have an actual assignment over this until after day 4. So be looking for some sort of activity that will go along with this unit or these sets of notes.